Let's take a moment to discuss what polar wander is. Polar wander can be a subject of quite a bit of confusion simply because it's not generally discussed in textbooks anymore. However, it is a very important topic to discuss because this is one thing that really led to us understanding that continents actually move. So, as you've learned, the Earth itself has two poles. We have a North Pole and a South Pole. And as you've learned, it's generally due to, a movement of charge, right? Now, as we've also learned, magnetic north, and geographic north are slightly different, right? There is a varying bit of degrees there, between them. Now, since we know that there are two poles, right, on our Earth, our North Pole and our South Pole, we've also learned that rocks record that polar position. As you learned a few slides ago, we learned about the Ch3 point. This is where we have a rock. Let's say here we have this continent, and we have some lava. Well, that lava, as it's originally liquid rock, here it's all liquid, is going to eventually cool down into a solid rock. As it cools, that iron and magnesium that's in there, if it's mafic especially, those crystals are going to line up and point towards magnetic north and south. It's just like if you had a bunch of shavings, magnet shavings, and you put a magnet near it. Those shavings would start lining up towards the magnet. Well, we see the same thing in the rocks, So we call that the Ch3 point, where our rocks are going to line up, and they point to north or south. Well, the confusion came in where here, let's say, and again, let's pretend we didn't know yet that continents move. Here is north. Let's say we're looking at a continent that's over here. And let's just say we're going to look at a rock that is 250 million years old. Well, let's say that rock from 250 million years ago says that north is in that direction. Well, that can be quite a bit confusing. Originally, what scientists thought this meant was that the North Pole was actually over here. So this would give us the appearance that north can wander, our poles can wander all over the continent. However, this idea led to two things, two possibilities. So let's say, let me draw this again smaller over here. Here's north. But let's say we have a rock. It's 250 million years ago. And it says north is over there. When we see something like this, it means one of two things. One, the poles have moved. And the continents stay in place. Or two, the poles stay in place and the continents move. So when we think about this, the more likely choice, which is going to move? Your poles or your continents. That's generally the idea. Today we definitely know that number two, that our continents are moving over the poles, is the much more likely choice. So what this means for our example there, that 250 million years ago, that continent we were looking at was actually over the North Pole. So here's its position 250 million years ago. However, let's say it's over here today, and it looks like this. Well, that's telling us that it has actually shifted and rotated in 250 million years. So we know that our poles do not move. Continents do. It was this observation Right? This whole idea with polar wander, trying to figure out which of those two things was correct, that help us prove that Wegener was actually right, that continents do move. So hopefully that helped you kind of untie what polar wander meant.